Okay, let's start. Thank you for coming to my session, and I'm very glad and honored to be here in Porto. Never been to Portugal. I've been all around the world, but never been to Portugal somehow. So it's my first time. Today I'm going to talk a little bit about what I call a journey in exploring how to do proper secret management in terms of a case I had myself within an organization about how we could do proper secret management. Anyway, first of all, I'd like to introduce myself. I'm Michel Schildmeijer. I'm from the Netherlands. I live in Amsterdam, or a little town near Amsterdam, actually. Switched to IT in 2000, studied pharmaceuticals, and now focusing on DevOps, CI/CD, and everything like those kind of technologies and methodologies. These are my contact details. And one slight commercial, I authored a book about CI/CD patterns, which is supposed to be coming out at the end of September with some co-authors as well. But it's now going to the press, and it will come out maybe next week or the week after. So if you want to order one, please be my guest. Anyway, security is a big word. It's a container word as well. It contains a lot. When you talk about security, you can talk about access management, or in my case, secret management, identity, all those kinds of things, hardening of your systems. Anyway, it's essential that security becomes more and more important. I don't have to say this to you. I think you all know that because of the situation today, about how the threats are coming in from all kinds of different angles. But what you see is that when you look at specific at software supply chain and development, then you see there's a growth rate of enormous magnitudes, like 742% increase of open source risks, malicious packets discovered, developer practices which need to be integrated with the shift left principle, which is not always the case, especially when you're starting up in software development. So all these kinds of industry trends, like trends which are affecting your supply chain, they all have to be taken into account when you look at security as well. So I'm part of a government organization within the Netherlands, a part of the CTO office. I'm an architect, and even in the board of the CTO, but also the business members which are included, they are aware that security is more like a business risk than before. So first of all, it was something which was lagged behind, came at the end of a program or a project. But now board members of business owners, they identify security as an important thing to do something about it. Because companies don't want to be at risk, they don't have any image damage, they don't want to have any disruptancy in their business. So it's very important to include security in every step of your process of developing and releasing applications. Now I looked at the conference hall, and I saw this board, and I saw a lot of stickers plaqued on the software development, a little bit less on security and software. So we need to do some work at that point, I think. Anyway, I was part of a government organization before as well as a solution architect, and this government organization started a big program which was called Groundbreaking IT. And it was about developing a cloud-native infrastructure, a platform for developers to land on and to develop new kind of applications, cloud-native applications, on a private cloud, disconnected for a big piece. So no multi-cloud, no public cloud, or minimal, but most of it was private cloud. One of that was It was container-based, microservices, cloud-native development, all those components, those ingredients which are essential for a cloud, modern cloud development platform. Anyway, one of the things we identified was that because we were starting up, we were looking at a lot of things around how is our developer workflow, how is our release workflow, but also how is our management of our passwords, our API keys and all those kinds of things. Well, we had identified this kind of flow where you can see your developers are building container images and push it to a registry and test it at some point, maybe some unit tests they do. The first risk you can identify is already on this stage. But also, when you push it to an internal registry, it can be an image which has some vulnerabilities inside which you don't know, which you're not aware of. But also external registry, if you are running in a public cloud maybe, and you have an external registry which you pull an image from, that could be also a risk. The other way around, the other thing is that when you manage containers in microservices in containers, then you also have your orchestrator, which is a huge platform which can pose any kind of risk on every level of an orchestrator, on an orchestrator level. And lastly, also the operating systems, the host, the nodes where the container platforms are hosted, they can also impose a lot of risks. So what kind of risks are we talking about? Like container landscape risks, vulnerabilities in images, like software vulnerabilities. When you're missing updates, when your images are in a registry and you don't do a proper lifecycle management, then you can miss updates, fixes, configuration defects, but also packaged malware, which you had pulled from maybe from a public registry, from a public Docker registry maybe, or untrusted images. So all kinds of threats which come in. Same for your registry where you store your images. You can have stale images again when you have images which are out of date, for instance. Insecure connections between the nodes of your container platform. Authentication is not well done, so everyone can access everything, or maybe in a sense that they shouldn't be there. And something like a kill chain attack, which we'll discuss now for a little bit. So a kill chain attack is in fact an attack of a hacker or a hacker group, which is usually highly automated, and it can be done. This case has happened in real life as well with crypto miner malware, for instance. So there was a company who had an application running on a container platform, and it was eating all kinds of resources. They couldn't detect what it was. They didn't know. So a lot of CPU was used, a lot of memory was used, and it seems that some crypto miner malware was packaged in images which were pulled from a public Docker registry. So when you look at such a kill chain process, then you can see the malicious Docker or GitHub repository where you pull your images which are infected at that point. And at some point you get an infiltration step where the malicious software tries to infiltrate into your network and do some reconnaissance. So scan around the network, scan around the host, which are the weak points, and go on through with lateral movement. So every time a little bit more deeper into your environment. And it's resulted finally in running crypto malware undiscovered, and yeah, that's really bad, I think. It can be much worse, like hijacking your software, for instance, which is also a case which is happening, or state actors, countries which are trying to infiltrate in your system and get all kind of information. It's not only these hacker groups somewhere in an attic which do this. These are usually criminals, organized criminals, or countries, state actors which execute these kinds of actions. So we look at the container landscapes like an orchestrator. You have a lot of risk as well, because when you look at a platform like Kubernetes, it was usually meant only to be accessed by administrators. So there was some kind of an RBAC model, but it wasn't sufficient. It wasn't sufficient for an organization, because there was not very good and secure around that. So you need to think of around a good identity and access management system, for instance. You also need to think about your network, so separate network, do micro segmentation or do node segmentation on your host where your container platform is running. Because if you compromise your entire host, then it can compromise the entire your entire network in that case. So another thing was this project, which I was part of. I was responsible for developing a container platform with a team beneath me, and we were starting up, and this was a company which was starting up as well. We were looking for a proper way of storing our all kinds of secrets, like passwords, like API keys, like SSH keys, like certificates. So we try to discover what is in the market, and what I'm trying to tell is not that the one thing is better than the other thing, but it's more like a comparison around what's there and what's good and what's better and what's for you, for which use case can you use what. Anyway, first of all, what are secrets actually? Well, secrets are all kinds of types of objects which you want to store somewhere where nobody can access it, only the ones who are who need it. And those are things like passwords, API keys, certificates. Already mentioned that, and you have to manage them, because otherwise they can spread everywhere in text files, maybe clear text files, for instance, and you don't want that. So challenges what you have, like secret sprawl, having secrets everywhere in a container, and you don't know where they are, and you don't do any rotation, and you don't do any lifecycle management around your secrets. Those kinds of things you don't want to actually when you roll out such a system, such a platform, enterprise-wide. So the common type of secrets I already mentioned, that API keys. APIs used for programmatic access to APIs. So system to systems, usually no people involved in between. The other things are passwords, of course, everyone knows those. Those are the most common types of secrets. And then you have SSH keys, for instance, to access a server remotely using a public and private key. And of course, certificates for encryption using HTTP, for instance. When you look at container landscapes, then you have several types of secrets which are there. When you especially look at Kubernetes, you have several types. First of all, you have the OPAC type of secret. This is the default, which is being used by Kubernetes as a default. And it contains user data. It's non-structured, so it doesn't have to have any validation. You can type in anything you want, as long as your application or your system behind it accepts it. So username, password, doesn't matter. There's no validation behind it. Second one is service account token, which are also created by Kubernetes, but these are not OPAC type of secrets. And you can use them for inter-service communication using service accounts, non-personal accounts for non-humans. Other kind of secrets are Docker configurations to connect to your maybe internal or external registry if you have one. I already mentioned SSH authentication and basic authentication for your HTTP. So usage of secrets, you can think of use it with your pod. So your application needs to authenticate against an external system or maybe an internal system like a database. And secrets can be set using environment variables, and can be mounted as a volume. So a pod can mount the volume using the secrets using for your application. So when you look at Kubernetes in this case, then you have your secret on the left side for you. The secret will be stored in a memory by the kubelet. So the kubelet holds the secret in memory. It's sent to the node, and on the node runs a pod which uses the secret, which can be mapped to the application to get access to it. So this is a simple flow of how a secret is used within Kubernetes. So when you talk about secrets, then you have challenges around how you manage it. I already mentioned it, like spreading it all around your ecosystem, having secrets everywhere, don't know where it is. Every attacker can find those and misuse them, and you don't want that actually. So you have to consider around a system which can manage this for you, which can store your secrets, which can distribute your secrets, and which can rotate your secrets, and which can prevent unauthorized users from accessing secrets which they don't need or which they're not allowed to. So it's also crucial for maintaining integrity, for instance, in your DevOps way of working. So your pipeline is also a part of it. It integrates your secrets management into your CI/CD pipelines is crucial for your delivering your software to your end customer. So the risks of poor secret management, well, they're obvious, I think. Your system can be compromised, unauthorized access, it can lead to a full system breach, for instance, or they can misuse your system for, abuse your system for, as I mentioned, with this crypto miner malware, for instance, and disruption of your entire operations, which you don't want to. So you have to have something which is robust, which also can be is available at all times, so you can pull back from earlier backups, maybe, if you have a system outage, for instance. So secure secret management in DevOps is also very important. So integrate your entire secret management also in your DevOps pipeline. So this is a little bit how it looks. You have your developer, which checks in version control, does a build to the CI/CD server. The secrets are fetched from the secret management system to return to your build, and then your deployment runs to your staging, your QA, and your production environment. All pooled secrets using tokens to validate your secrets against to. When the validation has been done correctly, then the step can go on. Now for our platform engineering, for our platform, container platform, sorry. For our container platform, we had to investigate 3 options, because there are a lot of options if you go around secret management. There are more, but we had to investigate 3 options, which was HashiCorp Vault, CyberArk Conjure, and Kubernetes sealed secrets. So the first of all we analyzed and we looked at was CyberArk Conjure. And why? The project or the program was actually built up in building blocks, which is usually an architectural method of how to architect an ecosystem. So they were building blocks, and one building block was, for instance, a container platform. Another building block was identity and access management. And all these building blocks weren't aligned very properly. So we had to actually investigate CyberArk Conjure because of the identity and access management building block was building this solution for doing like privileged access management, but also identity and access management, and also secret management. However, we were much faster with our team delivering our MVP, and this team wasn't ready yet, so we couldn't deliver a good MVP with good secret management at that time. So we look at CyberArk Conjure, and would be at the end it would be the solution to be used, but we had to go on with our product. So we investigate this, and CyberArk Conjure is an enterprise solution. CyberArk is actually more than only secret management, but for this you have a management environment which can be centralized. You have role-based access control, so you don't have to have access of unauthorized access, and you can do a audit trail, so follow all kinds of actions when accessing secrets. You have automatic secret rotation, which is very good, so you don't have any disruption in your operations. You don't have to stop anything like that. So it was our first choice because of the thing. It was the solution brought by the security building block. So this is a little bit of the architecture which we developed. So at your left, you can see our container platform. Which was running on OpenShift. Let me see, where's the light? Oh, here. Oh. Sorry for that. Yeah. So here you can see, at the left, you can see the container platform, the master node from OpenShift, and the data plane, the worker node. The application itself has a follower, which this follower is like a, it's not a sidecar, it's a different pod which runs and connects to the Conjure vault, and it redirects the secrets to the application in this case. So and this is how CyberArk Conjure works. You have your developer or your automated pipeline or anything like that. You have a Conjure database which stores all the secrets in this case. You have a policy engine for accessing secrets by applications like which are being used by authenticators. They provide access to your applications used by configured by policies. So you can configure all kinds of policies to get access to your applications. And you have your audit database for your audit logs, for your accessing the secrets. The second tool we investigated was HashiCorp Vault. So HashiCorp Vault is actually, compared to Conjure, more or less the same. They have the same capabilities. You can store your secret secure. You have dynamic secrets. You also have encryption as secrets, where you don't have to do anything with keys and everything like that. It will be done automatically for you. Leasing, renewal, recycling your secrets, and also audit logging as well. Why did we choose this one? There was another solution building block which was building an IT operations data pipeline, which consisted of Kafka bus, also a secret vault, and this solution was using HashiCorp Vault. So here at the left again you can see the OpenShift cluster running. At the right you can see the solution which was hosting the IT operations data pipeline. So the operations data pipeline was Kafka bus for interconnecting the messages, and they were stored in a elastic database for analysis later on. This was the initial setup, and part of it for secret storage and management they used HashiCorp Vault. Yet though we couldn't use this one as well at that time, because this was part of a solution which was built by the company which was providing this, and we couldn't get enough license ability for that. So the HashiCorp Vault was licensed for this solution only, so we had to buy extra licenses. So the management decided not to do that and wait for the solution which was coming out of the identity and access management. But this led us to investigate this option as well. So we looked at the HashiCorp Vault, and more or less it works the same as Conjure. So you have a vault database to store your secrets. You have a policy engine and authenticators as well to provide access to your applications. You have the audit database for logging, and you have your tokens for authorized external clients as well to get access to your HashiCorp vault using maybe encryption of a vault as a service, for instance. So we were focused on getting our MVP ready. So we also looked at a more, simpler solution, which still met our requirements at that time. Now not anymore, but at that time it did. So we investigated an option which was called Kubernetes Sealed Secrets. So Kubernetes Sealed Secrets is a mechanism of encrypting your Kubernetes secrets using a public and private key. So the public key is stored somewhere in a repository, and your private key is held by an operator and is being lifecycled by an operator. So you can secure everything like that. You don't need any centralized system. You can do it in your own cluster. Like for instance, we used multi-management clusters like OpenShift Red Hat Advanced Cluster Management, and we stored all our secrets, sealed secrets in there. So it can be integrated seamlessly with your OpenShift platform, and you can also do automated lifecycle management within your OpenShift. So what you need to do for that, you need to create a secret manifest to specify your secrets, which are base 64 encoded, as you can see. And then you run the sealed secret process, which seals the secret into a YAML as well, and you can store the YAML. And what I already mentioned, the private key is held by the operator package, which is running in this Kubernetes cluster. So the operator can only decrypt your secret, so you can easily store your secret into a repository, maybe even in a public repository, which I wouldn't recommend, but it can be done as long as it has no private key. It's useless for the rest. So this is a little bit about how the flow is around that. So you have you encrypt your secrets using kubectl. The external secrets operator, which is part of your Kubernetes cluster, will hold the private key and do the lifecycle management. And you can store your secrets using a CSI driver to store it on either on a repository or on a file system, maybe. Okay. A little bit about best practices. So these are all maybe more or less open doors, but yeah, especially when organizations are starting up, then they don't think a lot about shift left. They need to release, they develop application, they need to develop functionality, but start early with it. Don't wait until the end, like we did as well, because you then get into trouble in getting the right solutions for that. So avoid these things like hard coding secrets, although it's easy to do, but don't do it. Use a good system for it. Centralize your secrets, do good management around it, do good rotation around it, and restrict access only for those who are have to have access to it. These are a little bit of the comparisons around HashiCorp, CyberArk, and Kubernetes sealed secrets, where you can see that HashiCorp and Conjur more or less have the same capabilities and the same features. And I would recommend to use sealed secrets only to use for small scale environments, maybe only for development purposes to get used to of how it works. But when you go on and go to production, I wouldn't recommend using it anymore. For us, it was a little bit of a rescue to go on and to build our base in a full release. Anyway, at the end, we started using the centralized solution by CyberArk Conjur. Yeah, these are a little bit of comparisons around those two, CyberArk and HashiCorp, where CyberArk is more a suite of different tools like identity and access management, PAM, and also secret management, whereas HashiCorp Vault is more focused on specifically on secret and vault encryption and secret encryption and vault management. So these are a few of these the takeaways you can take with you to the next session, or maybe to your home or to your dinner. I don't know. So proper secret management is essential. It improves your productivity as well. It avoid unauthorized access and data breaches. Also, it avoids image damage. And one of the things which is really important is rotate your secrets, and rotate it dynamically. Like Kubernetes sealed secrets doesn't rotate dynamically as well. So you have to have something like a script for sealed secrets to update your public and private keys. And those other two do it dynamically and automatically. So you don't need to, you don't have any outage for that. Okay. Any questions? You can unlock your lock from your mouth. No? No. I don't know. Oh, okay. You have a question? In here.
And you mentioned licensing issues of both of them. All of them are paid, or HashiCorp is paid, CyberArk is paid, Sealed Secrets is...
Sealed Secrets not?
It's not paid.
No. CyberArk is a suite which you have to pay for. And the HashiCorp issue was because it was part of a solution which was built by the company. We had to buy more licenses, which would cost much more than the solution which was built by the identity and access management building block. So that's why we didn't choose for that option. It was a good option to be used in the end technically, but not financially.
Okay.
Yeah.
Thank you. That's
okay. Mm-hmm. I know. Yeah.
Yeah, and it's more in terms of licensing. It's less restricted.
Mm-hmm.
So yeah,
could be an option too. Yeah, yeah. But we focused on these three actually, so it could be had be an option too. But at that time, I thought OpenBOW was just coming because of the policy of HashiCorp raising all the costs. Yeah. So at that time, the solution wasn't there yet, or not finished. So. Okay, thank you very much for your attention. Have a great rest of the conference.